Hello and welcome to this video. In this video, I'm going to be focusing on operator overloading, a very important concept in C++. As you can see here, I've started the definition of a class called myInteger, which is nothing but a wrapper over a raw integer value. So what I'm trying to do here is I'm trying to actually create my own class, and I'm trying to carry out this operation here. Look at the line that I'm highlighting. So I'm trying to add two objects of type myInteger. So now that brings us to the question of what is operator overloading. So as you can see here, the plus, when I try adding two of these objects, the compiler flags an error. So that's because the inbuilt um, addition operator doesn't support adding two objects of this type, doesn't support adding two objects of type that you have defined. So that's where operator overloading comes in. Operator overloading refers to the ability, that C++ offers, where you can overload an operator like this plus sign, for example, and you can apply it to objects that you have defined. You can apply it to types that you have defined. So in this case, I've got a type here, a class called myInteger, and I'm trying to add two objects of this type. So that's what operator overloading is all about. It all comes down to up giving a new meaning to an operator when it's applied to operands of a class type. So how do we go about this, right? So let's go about it. You define something called an operator function. So you start the function, you write the function just like any normal function, but it always has the name operator. So I'm going to be defining an operator function plus, all right, which actually adds to myInteger objects. So since this is a member function, the first object is nothing but the dis pointer. I'm going to be calling this function with an object, with a certain object, right? So that would be the first operand, and I'm going to be passing the second operand as a parameter to this function. So let's say I do m2, all right, and what does it return? It returns a myInteger object. All right, so there's my function, and what's it I'm attempting to do? So I'm attempting to actually, all right, let me create a result object, and I say my result res is equal to uh, the this pointer, okay, plus m2 dot raw input. All right, so this is obviously not when you add these two, both these are integers, and this is not obviously going to give you a myInteger object right away. So let's say it's an integer, and then I create, or I can straight away return my integer of type, and I call the constructor here to create another myInteger object. All right, so now let me go down and see. Yeah, as you can see now the error is gone. So that's because the operator has been overloaded. Great. So how do we verify our output? So let me quickly define a display function which says cout, and I would like to display the raw input value. So let me add some message here. The internal value is the value of your my integer is okay raw input, and let me add a new line. So let's come here, and all I need to do is I call numres dot display. All right, so that's numres dot display. So I'll also come to I'll also explain how we don't have to call the display function, and how we can directly pipe the value to the output stream. So let's compile this and see whether it's going through. Yes, so we have succeeded in compiling this. So let me quickly just set a breakpoint here and let me run the code. And as you can see, we get final output. The internal value of your my integer is 132, which is what we expected. Awesome. So because 44 plus 88 is 132. So this is how you can add new meaning to the plus operator. So there are a few rules that have to be followed. For instance, I've written them down here. Let's go over them quickly. So you cannot overload the member operator, the dot operator, or any of the or the ternary operator. All right, and it's also not recommended to overload the logical operators or the comma operator. Now, I'll leave the research to you, and I'll be handling this in the reasons as to why this is not done in the advanced version of my course. So, operators, they can be overloaded as member functions or non-member functions. So as you can see here, in this case, in this example, I have overloaded it as a member function. So the plus operator, as we all know, typically takes two operands, the left operand and the right operand. So we always say A is equal to B plus C, something like this. So now in this case, the B here is nothing but the this pointer, because this is a member function. So we are actually, implicitly using the this pointer. And the second operand, the C here, is nothing but the M2 that I have passed into this function. So when you write it as a member function, you always only have to pass one parameter to the operator function. So it's always possible to also write this overloaded function as a non-member function. So for instance, you can always write it out here, operator plus, and you can say blah blah m2. Of course, you need to pass the type. All right, something like this. All right, and so this is possible too, right? Now, when do we do that? So when do we do it? So when do you use a member function? So, member functions, um, there are certain conditions. There are certain operators which have to be always member functions. So like, for instance, the assignment operator, the equal to, the arrow operator, which allows you to access members within an object using a pointer. You have the subscript operator and you have the call operator. So these are mandatorily supposed to be member functions. Now, when should you use a member function? If the state of the object is being changed. So for instance, um, besides the mandatory ones, you also can overload the increment or the decrement operators. So by increment, I mean this. So you have post increment and pre increment. These are recommended. It's usually recommended to overload these as member functions. So when do you use non-member functions? So for instance, so symmetric operators and whenever it's intuitive. So let me give you an example. By symmetric operator, so I mean, say 1 plus 2 is the same as writing 2 plus 1. So if you have a condition like this, so where you're adding an object a1 plus a2, and this is going to give you the same result as a2 plus a1, right? So it really doesn't matter that the first object that you pass has to be um, only a certain specific object. So you may be able to write a2 plus 1, or you should be able to write 1 plus a1. Both these should be supported. So if that's the case, then you go ahead and you write the operator as a non-member function. So that's what is meant by this first statement. And the next is when it's intuitive. So for instance, I need to do something like C out less than, the less than, the I'm trying to use I'm trying to output object one to the output stream here. So you could now write a member function, but in that case, the member function has to have the first parameter should be the this pointer to the OStream object, and the OStream object, the OStream class is a part of the standard library, and you cannot rewrite the standard library function. So what would you have to do? You would have to say obj1 less than cout. Now this doesn't really look very sensible, right? So there's no point writing a member function for this class and then passing it an object of OStream type. So that's when, so in cases like this, where it makes more sense to say cout obj1. Now this is when you will use a non-member function. So having said that, let's move directly to doing right that. So as you can see here, I've called the numres.display function. Now instead of that, it should be more intuitive to say cout num res. Okay, but as you can see now, the compiler flags that operation, right? Because this operator has not been overloaded to accept an object of of this type. Numres is of type myInteger. So let's go ahead and do that. So as I said, you cannot write it as a member function. So what we need to do is, let's now start by saying operator, and I want to overload this. And as I said, it's going to take an OStream object. So you always pass a reference because you can't create a copy of the OStream standard output stream. And I also need to pass the myInteger uh, object. Okay, so the myInteger object. And what's this going to return? This is once again going to return a reference to the OStream object. All right, so let me do that here. So I say OS and I say obj dot not necessarily to call display. Let me just directly say what's that gonna be? Yeah, you could call display, or you could just say raw input. All right, and let me add a new line. So now as you can see, the compiler is flagging this as an error because raw input is a private member. Now what we need to do is we need to declare this non-member function as a friend. All right, and we just have to say return OS. So let's comment out this, and as you can see, the error is gone. All right, so let's run this and see what happens. Awesome. See, you're getting the and 32. So in other words, this overloaded function has now been, this overloaded operator has been applied, right? So that's how you see it. So we can maybe add a little more, and let's see if we can say this is the internal value of my integer. So you can see how powerful this is. You can define your own output operations. You can just pipe everything into this output stream, and it should show up. So let's see how this goes. So as you can see, what we have, the message that we entered has shown up here. So, and that's proof that you have been able to overload the the left shift operator, and it's able to accept an object of type my integer to display anything on the console. So this is a quick overview of operator overloading. There's a lot more to be done with operator overloading. There are several operators that can be overloaded. It all comes down to first defining what your class needs to do. You don't, when you design your class, you don't directly jump into writing out operators which can be overloaded. You need to understand, what your class is trying to do, and then you see if there's a way in which you can overload the operators and make the entire thing more intuitive. All right, thank you, and I'll see you in the next lecture.